All right. So the problem reads, a disk is initially rotating at 3 radian per second. A bug lands on it, increasing its moment of inertia by 75%. What is the angular velocity of the disk with the bug on it? So this is about law of conservation of angular momentum. So we start with our solution by the formula. Initial angular momentum Li is equal to the final angular momentum Lf. And as we expand this, we will have I initial, omega initial is equal to I final, omega final. We are given in the problem the initial moment of inertia, rather initial angular velocity, which is 3 radian per second. We have omega initial, 3 radian per second. And we are given that the final angular, or rather final moment of inertia increased by 75%. So if our initial moment of inertia is I, therefore our final moment of inertia is 75% more than the initial moment of inertia. So we could say 1.75 I initial. So this is what we mean by the statement increasing its moment of inertia by 75%. So that means to say our final moment of inertia is 1.75 of the initial moment of inertia. The question could change to 25%. So that means if it increased by 25%, so the final moment of inertia would be 1.25. If it decreased by 25%, again, if it decreased by 25%, so the final moment of inertia would be 0.75 or 1 minus 1 minus 25%. So if it increased, you just add to you just have to increase the factor by the percentage. Any questions on this part? Any questions? All right, so now we substitute our values as we solve for the final angular velocity. So the initial moment of inertia is I, and our initial angular velocity is 3, is equal to the final moment of inertia. It increased by 75%, so that's going to be 1.75 of the initial moment of inertia multiplied by the final angular velocity. In this case, we will be able to cancel I initial, leaving us with 3. Leaving us with 3 is equal to 1.75 I initial. No, it has been cancelled. Omega final, and then we divide both sides by 1.75. Divided by 1.75. We have our answer, which is equal to 3 divided by 1.75. That is equal to 1.71. Unit would be radian per second. Any questions? All right. Now for number 7, your final moment of inertia here should be the moment of inertia of disk 1 plus the moment of inertia of disk 2, because it says here that they stick with each other and then eventually came up with the same or reached with the same angular velocity. So the moment of inertia final here, I final here, is the sum of the moment of inertia of disk 1 plus the moment of inertia of disk 2. For the last question on this slide, it says here that the skater decreased her rotational inertia by 50%. So meaning to say that's going to be 1 minus 0.5. So the final moment or the final rotational inertia would be 0.5 of the initial moment of inertia. So if it decreases, you subtract the percentage. If it increased, you add the percentage. Any questions? All right, don't forget to tap on please check on slide 33. And again, there's a drop quiz on Schoology after you have done slide 33,
So,
closes at 9:20. Yes, tell me.
how do we find the inertia of in question 7? The moment of inertia.
It's already given. The moment of inertia of the cylinder of disc 1 is given, and the moment of inertia of the second disc is also given. So you don't need to solve for it. It's given. You get that?
Yes, Mister. Thank you.
All right. Any other questions before I stop the recording and then let you continue working? Any other questions? Okay, continue now.